Assalamu alaikum dear students. Hope you are fine, you are safe, things are smooth and streamlined with you. I expect that you are using this time for your studies and other businesses very well. In the previous video lecture we did theorem 10.3, that was that perpendicular from center to the chord bisects the chord. Now in today's video lecture we are going to discuss about the converse of that theorem. Converse of that theorem means that if a line from center to the chord bisects the chord, then it must be perpendicular on that point. So what was given in the previous theorem? We were given chord. Let's have a look. It is chord, and if a perpendicular is drawn from center to the chord, perpendicular is drawn from center to the chord, then we proved that it bisects the chord. Suppose this is OB, means OD equals means AD equals DB. Now in today's video lecture, what we are supposed to prove, we have given that a line from center O, it bisects the chord. Now here we were perpendicular was given, we were supposed to prove it bisects the chord. Now a line is drawn, it is given that it bisects the chord. We are given that it is perpendicular to the chord. So converse. Recall that in the first case we were given perpendicular was drawn, we were supposed it bisects the chord. In the second case a line is drawn such that it bisects the chord, we are supposed to prove that it is perpendicular to the chord. So this is converse of theorem. It is theorem 10.4 mentioned in your textbook. Very simple theorem. So let us prove it. We will write the theorem. Yes, it is here. It is given that the line drawn through the center of a circle bisects the chord is perpendicular to the chord. So let us draw a figure. This is your chord. This is OD. Say name this M. This is AB. We will write the given a chord M is the midpoint of. No, we will write it another way so that you can have a clear idea. OM bisects the chord AB of circle. Recall that I will write it in a short form of circle C with center O, radius R. This is given. To prove, OM is perpendicular upon AB. What does that mean? This angle equals this angle, that is 90. Both should be 90. Construction: join OA and OB. So let us join them. This is OA, this is OB. So we will prove that first of all we will make these two triangles congruent. Very simple, we can make them easily congruent. Concept of congruent is very important, you know. So it is not only for this class, for the next classes also. So we have to prove that OM is perpendicular to the chord AB. Recall see the difference. In the previous video lecture we were given that perpendicular was drawn, we were required to show that it bisects, that is AM equals MB. Now here we have given that it bisects, a line bisects the chord, that is AM equals MB, but we are given that it is perpendicular on the chord. So let's prove it. So please, while watching the video here, pause the video to note it down because I have the unavailability of the space. We will prove it now. Proof: in triangles OAM and OBM, we will make them congruent. OA equals OBY, radius of same circle. OM equals OM, let us give the reason, radii of same circle. OM equals OM. Why? Common. AM equals MB. Why? AM equals MB. Why? Because it is given. How it is given? Because we are given that OM bisects the chord. You got it? I hope you will get it. So by what criteria? SSS. By SSS, triangle OAM is congruent triangle to OBM. By SSS, triangle OAM is congruent triangle to OBM. What happens when two triangles are congruent? Then their corresponding parts are equal, corresponding sides are equal, corresponding angles are equal. So we will write therefore angle OMA equals angle OMB. Why? Because CPCT, you know it, CPCT. But angle OMA plus angle OMB, this equals 180. Angle OMA plus angle OMB, this equals 180. How? Because these are what kind of angles? These are linear pair angles, and you know linear pair angles are always supplementary. Linear pair angles. Have a look. Two angles are equal and their sum is 180. So clearly each would be 90. So therefore angle OMA equals angle OMB equals 90. Angle OMA, this angle 90, this angle 90. It means, which implies that OM is perpendicular on AB. OM is perpendicular on AB. So you got it here. I will again explain it to you. Two angles are equal and their sum is 180. So clearly each would be 90. So OM is perpendicular on AB. This was all about in this question. This was theorem 10.4, converse of 10.3. So in next video lecture we are going to, let me check, there is one more theorem, I guess. Yes, and we will do some textual questions also, and we will follow accordingly our procedure. Thank you, class.